Okay, unfortunately I stopped recording, so let me go through the same thing again. First we find out what is the surface area of cone having slant length L and base radius R. If we open it, we get a sector of radius L. This length is going to be 2 pi R. Therefore, surface area of cone is going to be pi RL. Now we are finding out slant surface area of frustum of cone, whose upper radius is R1, lower is R2, and slant length is L. With some calculation, some similarity, we will arrive at formula for this, which I expect students to do. Pi into R1 plus R2 times L. This is going to be the slant surface area of frustum of cone. Right? So this formula is going to be useful to us. Now let us develop surface area of solid generated out of revolution. So let us consider a function from P to Q. If we wish to revolve this solid around x-axis, then it will generate some solid of revolution whose surface area we are interested in finding out. Okay, so what we do is we take one point here, we move further and then go here. Let this point x coordinate, wait, let me give the notation. This is delta x, increment in x direction, corresponding increment in y direction is delta y. Suppose this point is x, then this is x plus delta x. This is going to be y, x comma y, and this point is going to be x plus del x comma y plus del y, right? And then we join these 2 points, and when delta x tends to 0, we can use Pythagoras to find out this surface, the slant length. Okay, so slant surface of frustum of cone will be, for this strip, for this delta x height, it is going to be, using this formula, radius 1, that is y, plus radius of the second circle, it is y plus delta y, into L, which is slant length, that is radical del x square plus del y square. This is the surface area of frustum of cone. Maybe we can call it as, this is the surface area of this under consideration. Now, if we take all those small steps and add them, sigma goes from A to B, A comma 0, B comma 0. Sigma x goes from A to B, that is the summation of all of them. And if we take limit of this as delta x tends to 0, is going to be required surface area S. That is equal to, is that correct? Yes. Which is,
Could be a pi also.
And pi, yes, and pi somewhere, yes, pi. So we can write this, we know this is a notation for definite integral, and therefore, or maybe you can do one more step here. This is equal to limit delta x tends to 0, pi times sigma x goes from a to b, y plus delta y. This has to be in the bracket. You have to add them and then multiply by a radical. If I take out delta x square common, then it is 1 plus del y by del x bracket square into del x. Now this is equal to definite integral a pi times definite integral a to b. As delta x tends to 0, delta y will tend to 0, and hence it will be 2 times y radical 1 plus dy by dx bracket square dx. This is what is going to be our formula for surface area. Is it okay? This is y. So this is our surface area formula. Question? Any questions? Otherwise I give you numerical question. Find surface area of sphere having radius a. Find x square plus y square is equal to a square is the area, is the equation of the curve that you are supposed to consider. Upper part. So you want a dy by dx also, so you can directly 2x plus 2y dy by dx is equal to 0. Therefore dy by dx equal to minus y by minus x by y, and therefore 1 plus dy by dx bracket square is equal to x square plus y square upon y square, and y is equal to radical x square plus y square, which is equal to a. नहीं तो काय लिहिले हे, therefore y is equal to, sorry काहीतरी चुकी झालेली. Okay, therefore surface area integral 2 pi radical a square minus x square into root of x square plus y square upon y square times dx star minus a to a. Now if you evaluate this, you will get surface area S is equal to integral minus a to pi a dx, which will be equal to 4 pi a square. We already knew that this is supposed to be 4 pi radius square. Next, find surface area of spherical cap. This cap is a part of sphere whose radius is r and the height of the cap is h. Pada? Okay. So we are already found out this. Therefore, now only integrate lower limit is r minus h to r 2 pi r dx. That should be the answer, and it is 2 pi r h. That is the surface area of spherical cap. Curved surface area of cone. Find the curved surface area of cone with height h and radius r. So if we have a setup like this, this angle is alpha, then y is equal to x tan alpha is our equation of the curve. S is equal to integral 0 to h 2 pi y radical 1 dy by dx square dx, which is equal to h 2 pi x tan alpha radical 1 plus tan square alpha dx, which is equal to 2 pi tan alpha sec alpha to be evaluated x square by 2 between 0 to h. That makes it pi h square tan alpha sec alpha, which is equal to pi h square r by h radical r square plus h square whole divided by h is equal to pi r radical r square plus h square. The last problem, find the surface area of solid generated by cycloid by revolving the cycloid. X is equal to a theta minus sin theta, comma y is equal to a 1 minus cos theta about x-axis. Y in terms of theta already we know. So radical 1 plus dy by dx bracket square is equal to radical dx square plus dy square divided by dx, okay, which is equal to radical dx by d theta bracket square plus dy by d theta bracket square divided by dx by d theta into d theta. Is that correct? dx is imaginary upon dx by d theta. बरोबर चाललंय. काय करायला पाहिजे dx by d theta. dx cancel होईल into d theta. I think now it is correct. So this terms integral, what will happen eventually, the required surface area is to be found out from 0 to 2 pi, the entire revolution, because it from here to here it is 0 to 2 pi. Okay. Then you have formula 2 pi y. 2 pi, what is your y? A minus a cos theta. A minus a cos theta. That is your y. And then what is your this factor, this dx by d theta? We should do this calculation separately somewhere. Dx by d theta is equal to a into 1 minus cos theta, and dy by d theta is equal to a into cos theta, derivative minus sin theta, so a sin theta. बरोबर चाललंय. So a into a cos theta into radical a 1 minus cos theta plus sin theta into काय करतोय मी, मला सांगा जरा. बरोबर चाललंय. Okay, so instead of what we do is, instead of doing these things, we just find out dy by d theta into d theta by dx bracket square. Dy by d theta is a sin theta. X by d theta is a into 1 minus cos theta. So 2 sin theta cos theta for sin theta, sin theta by 2 cos theta by 2, and 1 minus cos theta we replace by 2 sin square theta by 2. So we end up getting cos square theta by 2 upon sin square theta by 2 for dy by dx bracket square, and therefore 1 minus radical 1 minus that is radical sin square theta by 2 plus cos square theta by 2 upon sin square theta by 2, that is 1 plus dy by dx square into dx. What do you do with this dx? Dx I can substitute by this expression, right? Dx is equal to a minus a cos theta d theta. So this can be this a minus a cos theta d theta. Okay, so this is different calculation. Now let us see what we have. What is this? This is 1 upon sin square So 2 pi integral 0 to 2 pi a into 1 minus cos theta bracket square this into this into 1 upon sin theta by 2 d theta, which makes it 2 pi a integral 0 to 2 pi. This is 2 sin square theta by 2 bracket square. Is it correct? Upon, are we getting raised to 3? Yes. Which is equal to 2 pi a integral 0 to 2 pi 4 pi a integral 0 to 2 pi sin cube theta by 2 d theta. This is integrated by substituting. You get 16 pi a square. Now, did I miss a somewhere here?
Yes, sir. When you multiplying the 2a minus a cos theta terms.
This a here and one more a here, so this should be a square. So this is 16 pi a square integral 0 to pi. When you substitute theta by 2 is equal to phi sin cube phi d phi. Okay, and then this expression is going to be equal to 32 pi a square integral 0 to pi by 2. I don't know, I might be making it long. Sin cube phi d phi, but it is correct. 32 pi a square into 2 by 3, which makes it 64 pi a square by. That is your final answer for this surface area. Any question? I mean, there was no difficult integral, it was just algebraic. Because it was in theta, we had to get into theta variable. Okay. Integral sign, Leibniz, which we will do afterwards because we are supposed to practice it more. And majority of the times you get the question on that, derivative under integral sign. Okay, so we will do it after the vacation, but before that I have some interesting things to do, which I will do now. Is if I ask you to find out derivative, differentiate y is equal to sin inverse 2x radical 1 minus x square. खराब हो गया. Differentiate this and tell me what is derivative. Is, yes, y dash is equal to plus or minus 2 upon radical 1 minus x square by chain rule. Y dash is equal to 2 upon radical 1 minus x square by x is equal to sin theta substitution, and y dash is equal to minus 2 upon radical 1 minus x square by x is equal to cos theta substitution. So maybe this is the most correct answer, plus or minus 2 depending upon which values of x you are talking about. If you try to sketch this graph, you will find positive as well as negative slope of tangent available on the graph. Okay, that is what is the explanation why you end up getting two answers, and plus or minus 2 upon radical 1 minus x square is the correct answer. If you report any one of the two, then you might be wrong. Okay, but then more interesting is find this integral. Integral 0 to 1 cos inverse 2x radical 1 minus x square dx. Let us see how do you get it. Okay, let us start writing and find out. Let me do substitution. X is equal to cos theta. Therefore, dx is equal to minus sine theta d theta. If x is equal to 0, theta is equal to pi by 2. And if x is equal to 1, theta is equal to 0. That makes our I as integral pi by 2 to 0 cos inverse 2 cos theta radical 1 minus x square. X is cos square, therefore it is sine theta into, this is done, 2 minus sine theta d theta. I think up to this point we have not made any mistake. If I take this minus sign and change the limit, I will get 0 to pi by 2 cos inverse. I can write down this as sine 2 theta sine theta d theta. Okay. Now, if it is cos inverse, then I have to have cos inside. Therefore, 0 to pi by 2 cos inverse. I will be tempted to write cos pi by 2 minus 2 theta sine theta d theta. Okay. Up to this point, I don't think we have done any error. Now, if we substitute any angle between 0 to pi by 4, if we substitute theta is equal to 0, then it will be cos inverse of cos pi by 2. Mind well, your cos is from 0 to pi. That is what is your domain for cos. So if we put theta is equal to 0, we get cos pi by 2. Therefore, cos inverse of cos pi by 2 is pi by 2. If we put the middle one, pi by 4, then what do we get? Pi by 2 minus pi by 2, that is 0. So cos inverse of cos 0 is going to be 0. However, if we put between pi by 4 to pi by 2, say 60 degree, then what we will get here is, let us put pi by 2 directly. So cos pi by 2 minus 2 times pi by 2, which is pi by 2 minus pi, that means minus pi by 2. So cos inverse of cos minus pi by 2 is not going to be minus pi by 2, but it is going to be plus pi by 2. That is the error that we will make if we directly start working from this point onward and write down. I just cancel this cos inverse and cos, because that is not going to be equal to pi by 2 minus 2 theta for entire range of angles 0 to pi by 2. It will be true, it will be pi by 2 minus 2 theta from 0 to pi by 4, and it will be opposite of pi by 2 minus 2 theta from pi by 4 to pi by 2. Therefore, we need to break this integral between 0 to pi by 4 and then operate this cos inverse cos. We will get pi by 2 minus 2 theta sin theta d theta plus integral pi by 4 to pi by 2, exactly opposite, minus pi by 2 plus 2 theta sin theta d theta. Check whether this is correct. Why it is opposite? You need to know. Because of the domain consideration of cos inverse. And now we are under control, and integral pi by 2 will come out from the first integral, pi by 2 integral 0 to pi by 4 sin theta d theta, that is first, minus 2 integral 0 to pi by 4 theta sin theta plus integral pi by 4 to pi by 2, minus pi by 2 comes out common, sin theta d theta, and then plus 2 comes out common, integral pi by 4 to pi by 2 theta sin theta d theta. These are the 4 integrals that we need to evaluate. Right? Move up. Okay. So sin theta is pi by 2. Integral of sin theta is minus cos theta to be evaluated between 0 to pi by 4 minus 2 theta sin theta. Theta sin theta is integration by parts, therefore theta sin theta comes out to be minus theta cos theta 2 times inside bracket नहीं चुकलं 2 times inside bracket minus theta cos theta plus sin theta. Check whether this is correct. Integration by parts to be evaluated from 0 to pi by 4. Then minus pi by 2. Again minus cos theta to be evaluated from pi by 4 to pi by 2 plus 2 minus theta cos theta plus sin theta to be evaluated from pi by 4 to pi by, good, that comes out to be pi by 2 inside bracket minus pi by 4 is minus 1 upon root 2 cos 0. काय चाललंय बरोबर चाललंय cos 0 is 1. अरे मग इथे चुकलंय मी लिहिलेलं cos 0 is 1, therefore minus 1 येणार नाही ते नाही plus 1 because minus दुसरं लिमिट सबस्टिट्यूट करू. Okay, minus 2 inside bracket, check whether this is correct, minus pi by 4 into 1 upon root 2 plus 1 upon root 2 minus 0. pi by 4 1 upon root 2 पहिलं बरोबर आहे, sin pi by 4 1 upon root 2 करेक्ट, 0 ने मल्टिप्लाय केलं त्यामुळे 0 आणि sin 0 is 0 करेक्ट, minus pi by 2 inside bracket minus cos pi by 2 0 minus minus plus 1 upon root 2. बरोबर आहे. cos pi by 2 is 0, so minus 0, and cos pi by 4 is 1 upon root 2 negative. से बरोबर आहे, मी इथे चुकलो. Is this correct bracket? I think so. 2 people are entering. Okay. And the last bracket plus 2 inside bracket pi by 2 minus pi by 2 into 0 plus sin pi by 2 is 1 minus plus pi by 4 into 1 upon root 2 minus 1 upon root 2. Is this correct? I have written exactly opposite in these two brackets in my notes. Why did I write these two opposite in my notes? Cos pi by 2 is 0, so minus 0. Cos pi by 2 is 0, therefore minus 0. And then cos pi by 4 is 1 upon root 2 minus plus it should be. So I think this is correct now. Okay. Then my answer is going to be different. Let us see what is the answer now. This is pi upon pi by 2 minus pi upon 2 root 2 plus pi by 2 pi by 2 root 2. This into this, correct? Yes. Minus 2 into this is minus root 2. This completes that, and this is 0. Then this is minus pi by 2 root 2. This is over. Then this is minus pi into 0. So this is 2 plus 2. Then how much is this? 2 means pi upon 2 root 2 plus pi upon 2 root 2. And then last term is minus root 2. Is that correct? Most probably. So this is gone with this is gone with this, and therefore you are left with pi by 2 minus 2 root 2 plus 2. This is altogether new answer that I am. This was the correct answer. I have got box made here. Plus 2. Pi by 2 plus 2 minus 2 root 2. That is correct answer. Last problem. Find integral (0 to pi by 2) sine 2kx cot x dx is equal to. Okay, here is the solution. This is equal to integral, let me use color blue, integral 0 to pi by 2 sine 2kx upon sine x cos x dx, which is equal to integral 0 to pi by 2 times inside bracket you have cos x plus cos 3x cos dot 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 plus cos 2k minus 1. Oh, k is equal to even here. Okay. So Dharma, you might be right. I should give k even number. Cos x dx. Now, how do we get this? I have demonstrated for k k is equal to 2 here. You can have a look at it, and therefore we are going to get something like this, which is equal to integral 0 to pi by 2 cos square x plus 2 cos 3x cos x plus dot 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 plus 2 cos 2k minus 1 x cos x whole bracket outside dx, which is equal to integral 0 to pi by 2 cos square x can be written as 1 plus cos 2x plus 2 cos 3x cos x can be written as cos 4x plus cos 2x plus what will be the next term, cos 6x plus cos 4x, right, plus dot 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 plus all terms will be 2 double every time, 2x 2x 4x 4x 6x, and the last cos 2kx dx. This is only once. All earlier terms from here to here 2 times, which makes it integral 0 to pi by 2 1 plus 2 times cos 2x plus cos 4x plus dot 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 plus cos 2kx, and outside we have dx. Okay. Now it is time to integrate because all terms are separate. So integrate 1 x pi by 2 to 0 pi by 2 plus 2 times sin 2x by 2 plus cos 4x by 4 plus dot 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 plus sin 2 times k minus 1 x by 2 times k minus 1 to be evaluated from 0 to pi by 2 plus sin 2kx upon 2k to be evaluated from 0 to pi by 2. Everything is 0 except first pi by 2. So I have to give in the beginning that k is even. Then only the answer is correct. Find sin 2k x cot x dx for k even integer, even positive integer. Okay, that is how the answer is pi by 2.